Thank you for the introduction. Yes, my name is Kristi Perreault. I will be talking today about Python development with AWS Lambda. But before we get into that, did some exploring around Florence and this beautiful city. And I don't want to make anybody jealous, but I was lucky enough to see the snake while I was here. So maybe you can get a chance if you check it out. On a more serious note, I am a very structured person, so I put together a quick agenda for us today, though I don't want to constrict too much. Cheesy Python jokes. So a quick introduction of who I am and how I kind of got to be here. We'll talk a little bit about what AWS Lambda and serverless technology actually is and what that means. As with anything, there are definitely challenges with this, so we will cover challenges in Python development with the cloud. Some more snake puns for you, but we'll talk a little bit about solutions and some support that we have in this space specific to Python. And then everybody's favorite topic is testing, so we will cover testing as well and how that can help us out here. And at the end, we will recap and have some time for questions. So a little bit about me. My name is Kristi Perreault. I am a principal software engineer at Liberty Mutual Insurance. I have been there for about 8 years, but the last 6 have been focused purely on cloud and serverless technologies and engineering. So I worked in our DevOps engineering space and have kind of transitioned into cloud education as well as engineering enablement and building developer tooling, a lot of which has been in Python. I am very involved and active in the AWS community, so I've done a ton of speaking events and podcasts, attend a lot of conferences, speak at a lot of conferences, and about 2 years ago I was recognized as an AWS serverless hero. My fun pandemic activity was getting a master's degree in electrical and computer engineering, so I do like to share that because all of my cloud knowledge and serverless experience has actually come straight from real-world industry experience, on-the-job training and learning. My background in education is actually way more on the hardware, robotics, hands-on circuitry end. So everything that I'm talking to you about today, I have learned in my job. I am from New Hampshire in the United States, so a little far from here. I organize the Portsmouth user group with a few folks, though I do spend a lot of time on this side of the pond, so I'm also a co-organizer of the Belfast Northern Ireland group as well. And I'm a huge advocate for women in tech, so I work a lot with young girls, inspiring them to pursue educations in STEM. I was very active in the local Women Who Code community up until recently, when they've unfortunately closed their doors, so I'm hoping that we can get some more women in tech organizations started up in their place soon. So that's enough about me. I wanted to set the stage a little bit here. Quick show of hands for folks in the room, and don't worry, I won't call on anybody. I don't like putting people on the spot. Who is familiar with AWS Lambda and serverless? Okay, so a lot of you. I don't know why you're here then, because this is supposed to learn about it. So I want to just kind of clarify what that means or what that is for folks that maybe aren't as familiar or haven't had a ton of hands-on experience with this. Since this is a Python conference, I do want to cover that Python Lambda is not the same as AWS Lambda, though they are similar in kind of meaning and definition. So they both are small functions that are used to do something. So a logical component, something that you can build. Usually a Python Lambda is much smaller. It can take a number of arguments, but it's typically only one expression and a couple of lines of code. AWS Lambda is a full-blown compute service offering from Amazon. So it is small, but small is relative here. It just means a smaller script, smaller compute, but it's definitely more than just a couple of lines. This is deployed to AWS as well, and they interact with a bunch of different services. So typically, if you're using an AWS Lambda, it's maybe triggered by something, whether it's clicking a button on a website and doing an API gateway call, or with storage, Dynamo, and other RDS options as well. So typically, a Lambda function will be triggered that way and can interact with other services. So you may use it to do a GET or a POST call and interact with a database or blob storage or something similar. This is not Python specific. You can use any language or most languages for AWS Lambda. Python is the second most popular one though. So there are a lot of Python developers out there using the cloud and using AWS Lambda. TypeScript is number one if you were curious, but we're getting there. We're almost caught up to them. So why might you want to use AWS Lambda? And as I started writing this slide, I realized that everything I put up here was also talking about serverless. So if you're not familiar, serverless does not mean that you are without servers. It just means that someone else like Amazon, Google, whichever cloud provider you choose, are managing those servers for you. So you don't need to worry about the underlying infrastructure. You don't need to worry about maintaining, patching, doing some of those things. You really just need to worry about your code and your business logic code. So AWS and Lambda and serverless are not the same thing, but we do use AWS Lambda quite a bit when we talk about serverless. So serverless is more of the larger philosophy, how you're building your applications and the architecture. AWS Lambda is a core compute service for serverless. So usually when you're talking about serverless, it's very common to be using AWS Lambda or the equivalent in other clouds, usually like Azure Functions is another big one. So they're both very scalable. You only pay for what you're using when they're running. Which makes it a really easy sell for the business and for your wallet as well. They scale up and down as you need them, so they handle the spikes in traffic that you may have. There's a lot of us that might have some more predictable workloads and kind of know so that this can handle it for you. Quick and easy I debated putting up here, because as we'll learn in these slides, and depending on who you are and what you're working on, some people find this very easy to work with, quick to stand up. Some people don't. Usually with things like startups, smaller applications, greenfield applications, this is really easy to get started with and get moving with. Sometimes in larger enterprises or with legacy code that you're migrating into this space, it can get a lot more difficult and complicated with using these services, but we'll talk a little bit about that later. I mentioned a couple times the event flow, event-driven, so usually serverless is very event-driven, so your Lambda function is going to be triggered off of an event, like a button click on a website, and then that'll pass the event along and return something to another part of your process or even directly to your users. And as I mentioned, this is a managed service, so you only have to worry about your business logic code, some basic configuration setup, and AWS or your cloud provider of choice will handle a lot more of the underlying infrastructure for you. A big one here is security too as well. So typically we say that you are responsible for the security of your application. AWS and your other cloud providers are responsible for the security of the cloud. So you don't have to worry about securing the data centers or the actual hardware. You just have to worry about managing access to your application with policies and roles and some of those other things. So now that we've had 2 slides talking about serverless and Lambda, it is time for your first assignment. And it is a Saturday, it is the end of the conference, so don't worry, you guys don't have to do anything. I will do all of the hard work here. But let's say that your boss, your tech lead, whoever it is, comes to you with a list of requirements, and they're pretty granular, so you know that an event's coming in, probably off of an API gateway call, maybe a post. And you want to do some really light data manipulation on that. So again, this is Lambda functions, so relatively small. We're not talking data lakes and really large data sets here, but small things that you might want to adjust or tweak or update. And then you're going to upload this to an S3 bucket, which is AWS's offering for blob storage. So that would be kind of like a file system. You can put anything up in there. And for this case, we'll talk about maybe JSON files. And then you'll want to deliver a return status to the application or the user. Now, most of us are Python developers, engineers, architects, so we translate this into our technical requirements. So we're sitting here looking at this and thinking, well, definitely going to want some logging and observability in here to see what places of my code are running, where I might be getting into errors, and kind of just overall looking at metrics and things that are happening in my application. You'll want to handle those errors as they come through. And even though this is pretty light data manipulation, Python has really awesome libraries available to us, so we may have a lot of imports, libraries, things that we want to take advantage of and bring into our Lambda function. And finally, with any good application, we want to have really robust testing. So infrastructure tests come along with working with AWS in the cloud, as well as unit test, integration tests, whatever else you may want to use to test your applications. So you say to your boss, that sounds great. I got a 5-minute overview of this from Kristi, and it is brand new and greenfield, so I know exactly what I'm doing. This will be quick and easy, as she said, right? Not necessarily the case. So you start developing and you kind of realize that you're running into all of these challenges and these issues with using Python. So just because you went to the cloud and it's the latest and greatest thing doesn't mean it solved all of your problems for you. So you start seeing things like managing dependency conflicts, running into package sizing issues. The biggest one I've seen a lot lately is local versus your deployed environment. It's really hard to emulate those AWS services locally, and it's really hard to recreate that deployed environment so that you can test adequately. Lambda is built on Linux, so anything involving working with the file systems and OS libraries can be a huge headache. I've experienced that firsthand with building developer tools for different platforms. That can be really difficult. And then we're injecting environment variables. You start talking about things like API keys and secrets and the regions that you're deploying to, and this can get very complicated pretty quickly. The good news is there are a lot of very Python-specific tools and technologies that are out there that can help us out with that. So we have some solutions that we can use at our disposal. The first one of these is one of my favorites. It's called Lambda Powertools. If you know me or work on my team, I push this library constantly to the point where people think I am getting commission for it. So if you do end up using it, make sure you let Ada or Lessa know on the AWS team so that I can get my check cut of this, because I have definitely promoted this a lot. So from their documentation, they straight define Lambda Powertools as a developer toolkit that implements serverless best practices and increases developer velocity. My second statement here is kind of my own twist on that and what my experience of that has been in more layman's terms. So it's like a wrapper library that helps you simplify your application observability using things like annotations and really straightforward commands. So out of the box, they offer a lot of great features. These are their core ones. So there's a tracer, if you're familiar with things like OpenTelemetry and AWS X-Ray. This is like a wrapper for that. So you're able to incorporate those in your Lambda functions without too much headache and standing up some of these instances. A logger, hopefully that's self-explanatory, but if anybody in here has used AWS, you know that the logs are not always the best. They're not very explicit. This helps you with some more visibility into your applications and your Lambda functions. They have some really cool features with metrics. So they're able to actually send metrics directly to a CloudWatch dashboard for you in just 1 or 2 commands, as well as even forwarding those along to Datadog. And the last one is the event handler, which is probably the one I've had the least experience with, but it works really well with your API integrations, routing, and endpoints. And the thing that's really cool about Lambda Powertools for PyCon is that it was developed with Python developers in mind. So this is a Python-first library. They've just recently started expanding into other languages like TypeScript, but the advantage here is that we'll get the first features, they're tested with us, and they have the most released so far for Python developers here. So I was hoping I was going to be a little bit closer to the screen to point some of this out. So hopefully you can see this okay. I am definitely not a live coder, so I pulled some code samples from the Powertools documentation just so that you can see how easy this is to work with. So the top left is our logger. You'll see on line 1, we import the logger. On line 4, we instantiate it. And then in log 7, there's an example of an annotation there. So you're injecting some basic Lambda context to enrich those logs that are coming through for Lambda functions. And then you can see on line 9 and on line 12, you're using the logger as you normally would. So these are logger.info statements, but they also have debug, error, and the different levels that you're used to as well. And you can see on the bottom left here that this is what it looks like now. So it's added those pieces in blue for you. So you get more descriptive messages, as well as more information about your function, like the name, the memory size that you're using, the ARN, and the request ID. The metrics is the second one I probably use the most out of these. Almost exactly the same as the logger. Your first line, you import the metrics. Your fourth line, you instantiate them. And then this one on the 7th line, we're actually doing an annotation to capture your cold start. So working with Lambda functions because they spin up and down when you need them. There is a little bit of warm-up time if you haven't used it for a bit. So this cold start metric gets captured here and will tell you whether or not that run of your Lambda function involved a cold start time. As I mentioned, you can also create custom metrics. And again, line 10 here, all you do is add one metric. And you can create, this one's a booking example with a unit and the value. So these can be kind of anything you want, and it's super easy to send this to Datadog as well. So this covers a lot of that logging and observability that we need for our assignment. So we continue to code, we continue to work out our Python logic. We go to deploy this, and we realize that you have a lot of imports that we just brought in, right? We kind of predicted that. And AWS has an offering called Lambda Layers, which helps you separate some of these dependencies from your logic. It's a supplementary zip file that zips up all these dependencies for you, and you can share this across different Lambda functions. So if you're using the same dependencies or doing something very similar in another function, you can reuse that. AWS and third-party also offer other layers. So in the example of the Datadog metrics, that's actually offered as a layer. So you can just bring that in, add it to your Lambda function, and you have everything that you need to forward to Datadog. You can have up to 5 layers on a Lambda function, but those cannot exceed 250 megabytes total with your Lambda function logic. So it's very important to know that because as we're continuing to build this out, we actually realize that our package size is way too big for that. We are not going to fit in that Lambda function. But you don't really want to re-architect your entire application. You still want to take advantage of things like Lambda Powertools. You don't really want to move away from Lambda. And lucky for us, AWS also provides another tool for that, which is containerization. So if you're kind of in the AWS serverless or containers world, these are kind of two conflicting ideas that can butt heads a little bit. There's a constant rhetoric around serverless versus containers. This kind of melds those two things together quite well. So these are Linux-based container images, and it's basically what it sounds like. You can containerize your Lambda function. You can use AWS-provided regular or OS-based images for custom runtimes. You can also bring your own and create your own, which is great when you work at a large enterprise like mine, and you have all sorts of special requirements you need to use. The caveat to this is that you must use Amazon's ECR service offering, so that is the Elastic Container Registry, so that's where they keep the base images for you. But you can see we can use up to 10 gigabytes of data. So this is way better for working with those larger package sizes, which tend to happen with a lot of these Python libraries. So even though you have a small amount of code, you're bringing in a ton of dependencies, you can still make use of Lambda functions. Now, when might you use one over the other? Because these things are kind of similar. Like I said, the layers are really helpful when they're AWS provided or they're custom ones, so somebody else is managing the dependencies for you. You kind of know what you need. It's there already. It does actually reduce your deployment time by a very small amount, and it's really helpful when you have a lot of smaller libraries that you want to share across functions or across projects. I will say, since you all have stuck with me till the end here, my kind of insight on this is that most of the time, if you're considering a layer, you might want to just jump into containerizing because you are usually hitting that larger library, larger package size. So once you're at the point of kind of considering layers, unless you're using one that's provided or you're going to share them, Containers are kind of your easier bet. I've definitely worked on projects where I've started with a layer and just kind of ended up on the other side with containers. It helps you with managing a little bit more dependencies. You definitely have more flexibility. The downside is obviously your deployment times are going to be much larger, but if you're not deploying that frequently, it's not that big of a deal. It does, however, improve your cold start time by a small amount as well. So one of the other AWS heroes, AJ, has written 2 really great blog posts kind of comparing and contrasting layers and containerization, and he's done some performance runs on these and has some very interesting results to showcase this cold start time on the containerization. So I will share those and include those at the end for anybody who's interested in checking those out. But they do go much further in depth between the pros and cons between the 2 of these. Now we've kind of talked about developing our function. It's out there, it's in the world, it's working as it should. We may need to update some things. And how are we going to maintain this going forward? How are we going to continue to work with this? And this is everybody's favorite topic, testing. Now, as a Python cloud developer, I'm actually surprised that not more people know about the python-lambda-local package. This is, again, one of my favorites to bring in and work with on projects. It's a quick, lightweight pip install. And it's just a CLI command that allows you to run your Python Lambda functions locally. So it's a great, lightweight way to run your Lambda functions without having to emulate a ton of things or stand up a ton of infrastructure. You use and send it a mock input as your event, and then you pass in environment variables and some local configuration if you'd like. And I tried to kind of point it out here, the different components of this in the different colors. So all you have to do is run your Python Lambda local. The yellow is just the path to your function that you're going to run. And then in green here is a path to your test event that you're going to pass through. So I usually create like a test data or test event folder and put a whole bunch of different examples in there of different ways that I might expect events to come in, errors, happy paths, different configurations, and then you can kind of run through all of those. Optionally, in the purple, you can add in environment variables if you need that for your Lambda function to run, and then a quick timeout value, which usually this does not take that long to run. So this is a super powerful library that I really like to use when I'm testing locally. It saves you from having to keep deploying this up and maybe clicking the button in the console and pasting in new events. You have them all right there with your code, and you can package that up with your testing. Now, some of you may have heard of the Moto library. I can't talk about Moto unless I talk about Bodo. So Bodo is the library that you use to interact with your AWS services within your Lambda function. So if we think back to our assignment, one of the things we want to do is upload to an S3 bucket. How do you do that? It's with Bodo. So Bodo, you can stand up a client or a resource. So we'll create a bucket maybe with S3, and then you can simply do an S3 put object, and you put in your key for your file as well as the data for it, and then point it to the bucket you want it to go to, and you have uploaded to your bucket. Moto is Bodo's mock library, so they were very clever with mock Bodo, becomes Moto. It allows you to mock these standard services for your unit tests. It's not meant to replace anything else, but it is really complementary to things like PyTest that already exist. And again, this is something that is very specific to Python development with Lambda. So I have a couple more code examples straight from the documentation again. So the top one is your actual code. As you can see, this is pretty easy, exactly how I described with importing Bodo. You're going to set up a client with S3, and then you're going to do a put object. So that's exactly what we want to do in our assignment today. And then the test is a couple of different lines. There's a couple of different ways you can use Moto to mock in your tests. This is one of the easier ones, so you can see on that fourth line there, you're just bringing in a mock AWS annotation, and then you're creating your resource, and it knows that that'll be your mock that you'll want to use within your tests. As I mentioned, it works really well with PyTest as well. So this one on the right shows some PyTest fixtures that you're going to initialize your tests with. And you can do a with mock AWS and yield the client and create the S3 bucket there as well. So there's a couple of different ways that you can kind of implement this in your tests. These are some of the easier ones, but the documentation covers some really good ways to do this as well. Now, the last one that I want to talk about today is actually not AWS Lambda specific, but it is Python specific. It's Tox. It is a virtual environment manager that helps you run your tests. Again, super powerful tool. I do use this in all my AWS projects, and I encourage my teams to use this as well. Kind of like your package JSON just for tests, or bring in your requirements that are just for your tests. You're able to point it to your test paths that you want to look at, as well as set up your own environment variables here. If you don't want to initialize that in a PyTest fixture, you can do that here. And then you can set up your own commands. So I like to use Poetry quite a bit. So we have our Poetry runs in here. And you can even set up different ones like unit testing, integration testing. You can even set up linters and things in here as well. So you can run Tox unit, Tox integration, run all those things separately, or run them all together just with Tox, TOX. So this is a very low left thing to add to your projects, and I think it makes all the difference and definitely saves a lot of time when you're working with your cloud. So we've implemented all these things in our project. Congratulations, it was a huge success because we took advantage of all of those great Python libraries and tools that are available to us. Hopefully we have learned something from this, and you can go and enjoy a gelato. First off, I can definitely chill on the snake puns and the snake pictures. I definitely thought he was too cute and went a little too overboard, but we'll relax a little bit on that after this. Just kind of in summary, Lambda is a really powerful cloud compute service, but that doesn't mean that Python issues go away or don't exist anymore. It still can be really difficult to develop with Python in the cloud. We do, however, have really awesome, up-to-date, made-for-language Python tools that can help us out when we're developing in this space. Tests are still definitely important. They are very complicated in the cloud world. We do our best to kind of work with and emulate deployed environments as much as we can. It's not always the most perfect thing, and sometimes you do need to manually test. But we have really cool tools like python-lambda-local, Tox, and Moto to help us out with mocking these services and hopefully not make them too complicated. And I hope everybody here can sort of walk away with this idea that they can build fully serverless, scalable applications with Python in AWS or any cloud of your choosing. So it's maybe not the quickest and easiest way, but there's definitely a lot of guidance, a lot of support out there for you. And on that note, feel free to take pictures of this if you'd like, but there are tons of great docs out there. The Powertools docs is some of the best that I've seen in kind of the tech world. Some of the AWS docs are okay. They're not too bad, but they can get you started. And then, as I mentioned, those two articles from AJ I've listed on the bottom as well here. So he does a really great job explaining containers on Lambda and how to use them. And actually his talk on layers is exactly why you shouldn't use them. So it's a very interesting read. I encourage you to check it out. That's all I have for you today. Again, my name is Kristi. I am a principal software engineer and serverless hero. My social medias are up here as well. If you are ever in the New Hampshire, United States area or the Belfast, Northern Ireland, we would love to have you join us at our user group. We are always looking for more attendees and more speakers. And on that note, we are actually running our very first Community Day event in Belfast in September. We just opened the CFP this week, so definitely check it out and send it to your friends. This is a free event to attend as well, so we would love to have you there and would love to learn from you all. Thank you.
Thanks, Kristi. So we have a couple of questions from Slido. So the first one is, what happened to the servers when it's not being used?
Yeah, that's a great question and probably one of the biggest ones we get when talking about serverless. So AWS actually has all of their own data centers. So typically, it may or may not be in use by another customer of theirs. So they'll kind of spin it up as they need it. They have tons of different regions and what they call availability zones all over the globe. So they'll utilize kind of what's closest to you based on what's available. So you don't actually know the specific data center that your code is running with at any given time for security purposes and reasons. But it is probably in use by another company or individual that is using the compute and the storage there. So you can reserve it if you want. That's more with things like EC2, which aren't serverless, but they'll kind of dedicate that space to another customer or save it for someone else or something else later.
Okay, thanks. So another question. Any recommendation regarding which Python version to use on a Python Lambda? Namely, is Python 3.11, 3.12 working well there, or is it just supported on paper?
Yeah, I think, I don't know if you caught it, but on my talks, I'm actually using Python 3.11 in that one. So 11 and 12 are definitely, I'm pretty sure 12 is now supported. That is another kind of pain point, is having to manage your Lambda function versions. So they do a pretty good job at advertising when they're going to go out of date and when they're going to stop supporting it. One kind of gotcha with Lambda functions is that if you don't touch it or redeploy it, and like it's just out there being hit every so often, and it's 3-4 years old, and then that Python version goes out of date, you don't have to touch it; it'll still keep running. But as soon as you go to deploy it again, it'll prevent you from it unless you update your version to the latest. So that is kind of an interesting gotcha with Lambda functions, but they are pretty good at supporting the very latest and greatest out of the box, so you don't have to worry about that.
Okay, so another question. Can I use python-lambda-local to test local Docker images, which will be later pushed to ECR, or am I allowed to test only layers?
Yeah, I think that it is just, I don't think that you can use that library with containers. That's a good question. I might have to look at that. But you can with your regular function code. With layers, it shouldn't matter too much, like things like the Datadog layer, for instance. Like you might not even want to test that that's going straight to your Datadog metrics dashboard. So if you're like okay with kind of ignoring some of those pieces of it and just want to test like basic functionality, like in this case, the data manipulation piece, it should still run. It might just not, forward off to where you want it to go with the layers. But yeah, the containerization and the local testing is very, very tricky with Lambda and with AWS services in general still today.
Okay, thanks. So another question. How do you manage AWS Lambda's cold start and statelessness in Python?
Yeah, that's a good question. So I'll say out of all the languages, I think Python is actually one of the best with cold starts. They're very, very, very short or minuscule as far as Python goes. If you're using Java, that's kind of where you notice a lot of that cold start time going to. So it isn't quite an issue. If it's something that's kind of running continuously too, you're almost never going to run into the cold start problem. You can do things like the containerization that might improve some of your cold start time, but it's usually not much to notice a huge difference.
Okay, so we have another question. Do you also use serverless offline for local testing?
I do use the serverless, what was that? I'm sorry, you skipped it already. Was that somebody in the room that wanted to ask it?
I don't know, it's something in the room?
Yeah.
Okay.
Oh yeah, yeah. You can, yeah. So you can use it. I think you can use it offline. It's the serverless stuff is kind of like your whole architecture. So the python-lambda-local piece will only test the Lambda function piece of that. It's not going to like test your services end to end. I hope that they're working on something cool that would do that for you locally. The emulating locally is like one of the hardest parts, but it will help you test, like when we're thinking about like Python and writing our logic to kind of do those commands for us, it will test like your basic functionality that you kind of can do locally, but anything interacting with a lot of the deployed services is much more difficult. The mock events can kind of help with that, but it's not great, unfortunately. So we've been pushing on it for sure.
Okay, thanks. Now another question.
Okay.
How do you
It's a marathon in here today, all right.
how do you usually deploy Lambdas on AWS? Any framework?
Yeah, there's tons of different ways that you can deploy. So I work in an enterprise, so we're a little bit stricter with how we can deploy. So we use things like Bamboo. But there are a whole suite of AWS offered services like Code Deploy, Code Pipeline that you can easily hook into and deploy. If you don't have a ton of like enterprise restrictions and things too, you can also code directly in the console as well. So you can write Lambda functions and just click of a button, test them, and it'll work in that deployed environment for you too, if that's something that is available to you. And that's a really quick and easy way to get started. And then you can kind of move into this world more of infrastructure as code and utilize things like CDK, SAM, CloudFormation, and create these Lambda functions more in your code and in GitHub and deploy it up. So yeah, definitely if you're getting started with this stuff, if you're working with it on your own, I would check out some of the AWS tools and services that they offer because they have tons of developer tools available to you.
Okay, thanks. So a question on slide or over. If anyone want to ask a question, otherwise Kristi will be available.
Yes, I will be here for at least
conference.
another hour or so, so feel free to come find me. I love to chat AWS, and if you're interested in community stuff at all, please let me know.
Thanks, Kristi.
Thank you.